Oh, thank you. Yes. So every book club we're supposed to, that's one of the things that helps save the John, the guy that does who runs this book club, a lot of effort is if you put the little start message in the chat so that he knows when to start recording. And once again, I've forgotten to do that. So thank you so much for doing that, Dick. Any event. So this is chapter one. This is this chapter is intended, first of all, just kind of give a introduction to the topic, but also to go over it at a high level what the different data sets are available to us, or some of the data sets that are available to the Hill that will be used in this book. That was my take on it. So we did a little book club overview. Now we'll talk about the data sets. So the yeah, so this is Analyze Baseball Data. I already said that. This is where the repo is, but the link is actually in the Slack, so don't worry about that. And the goal of this whole book is to learn how to answer baseball questions with data. So we'll learn how to access data. We'll learn how to manipulate and analyze that data with R and the tidyverse. Many of you are already familiar with R and the tidyverse, so some of those parts will go by smoothly. Others will be like myself, will enjoy the review. So we'll see how it goes. And finally, there's a section toward the back about how to communicate these results to others using Quarto and Shiny. So if you've not used Quarto before, there's a chance to learn about that. Even if you have or have not used Shiny, there's a chance to either learn about Shiny or exercise your Shiny skills, I guess, at the end of this book, which would be kind of fun. Shiny baseball, I like it. So some of us are not baseball experts, myself included. I do enjoy watching baseball, but I don't know all the terminology. I don't know, like I had to look up again and remind myself what the difference between a plate appearance and an at bat is, because that's important distinction to make in the data. There's all that kind of stuff. So the MLB has a glossary. I haven't pushed these up to the repo yet, but I will. I guess we could also put these links on Slack so that people have them more readily available to you. But MLB, you can or you just Google these things, right? MLB has a glossary. There's a cool website called Baseball Reference. Actually, I can just it has all kinds of glossaries and definitions and what different statistics are. It's anything you want to know about baseball is probably on here somewhere. And then finally, there's the rules of baseball. Hopefully, you won't need that, but if you do, that's where you can find them. It's not the kind of thing you can learn how baseball works. That's the best way to learn how baseball works is probably watching baseball and trying to figure it out. Kind of how I learned well, as much as I know about how rugby works, that's how I kind of learned it. Like, what are these people doing? Yeah, but of course, always ask questions if you have them. Okay, where was I at? Okay, that's terms of baseball. All right, so there's several databases he talks about in this chapter. The first one is this, I don't know how to pronounce it correctly, but I'm going to do my best guess of Lahman database. I don't know if that's correct or not. And this is the highest, the data goes into lower and lower level detail. So this is the highest level of detail. This is season by season data from 1871, which is just overall results of what happened that season, how many games were won by each team. And then it also has uh, details of like who the players were, what the batting statistics were for the players, what the pitching statistics were for players, and fielding statistics and overall team performance. So these are all for the whole season, not by each game, for example. So you can find out how well Babe Ruth did in pitching in a certain year, but well, actually, you can find out for a certain stint if he was playing for multiple teams, for example. But so it's very high level data. But he will use this a lot in the book. Uh, one reason that's a lot of useful stuff in there, but it's also pretty easy to get from R. There's a library called Lahman, and this is something he'll show us next chapter. I thought I'll just um, show how it's done. So you can just after you added this library, you just call it, and then I get all these warnings, of course. But then you can just say, hey, give me all the teams data. And what does it look like? So every year has the teams, what their franchise ID, what their rank was that year, how many games they won, all that high level stuff you might get from ESPN, for example. But it goes back to 1871. That's the cool thing there. I see somebody wrote something in chat. Feel free to interrupt if you have interest in things like this. This is interesting. So They built this database. We say back in the day of slow internet, yeah, sure, right? Because it's a small file now. Well, back in the day, probably was the buzz. All you could stand to wait for the download, for sure. And so in the book, they say this is good for answering questions about the average number of home runs per game, or what's the percentage of games completed by the starting pitcher, or which player had the most walks per plate appearance, the so-called bases on balls percentage in a given year. So these are all things you can get from this database, the Lahman database, from these different tables. So, and then the next data set he talks about is Retrosheet. This is a game by game database. Actually, it's got two sets of data. It's got a game by game and a play by play. So the game by game data has game logs going back to 1871. So it gives, again, total offensive and defensive stats, the starting players. There's a website that you can find a link that gives you the description of all the 161 fields for each game. So instead of a season, now it's a complete summary of the game. For that game, what was that player's based on ball percentage, or what is that player's batting average, for example? And these are big files, so there's a repo that goes along with this book as well that has some tools and stuff that he presents, and also has some data for. I think it has some sample data from all these other things just to support the book. It doesn't have the full data sheet, so if you need something more, you'll have to get it yourself. And you can get them from this website, the Retrosheet game logs. They're all just zipped CSV files. I think we'll probably learn more about we will learn more about how to access these things in future chapters, though. So don't worry about that right now. Now, the interesting thing are these play-by-play data sheets. If you've ever seen somebody score a baseball game where they keep track and they have like a little pad and they write down what was the put out, or what was how the players advance. It has that level of detail in it. It's coded in a way that it's hard to decipher without a lot of work. Like going through, there's a detailed description on the Retrosheet website of what each line is, but in each line is what they call an event file, and it has data for each play that happened for that game. So it's pretty detailed. So this is an example line right here of a play field. It says, oh, this, and so what does this mean? 3, 1, who's this? What's this? What's this thing in the bottom here, right? So you can translate that. What it really says is, well, in the third inning, the visiting team, that's the one, Bo Bichette, that's this player's name, which you can look up in a different field in the same file, with, let's say 0 strikes and 1 ball, right? Called strike. So this means it was a called strike. And then this X means that was the play that happened. And then this string here says that, well, you got a double, the line drive through the center and right fielders, I guess. Then this, it says that there's, I think this plus means that there was some, something went wrong and that allowed the runner to advance further than they should have. So it was kind of maybe not a true double, I'm not sure. But any event, this other field here at the end tells you that the player on first also advanced to third base line. So it's just very detailed play-by-play action, enough that you could actually reconstruct kind of at that level anyway, what happened, just like you would do if you're scoring a baseball game. So we're not expected to, in this course, translate this. Instead, he's going to provide tools and actually Retrosheet provides tools as well to parse these things and get the information you actually want out of it. How that works, I don't know. We're going to learn. I look forward to it. But I certainly wouldn't want to have to write my own code to figure out this stuff. Oh, yeah. So here, I knew I had something to say about this. So Retrosheet does provide some tools. Unfortunately, they're like old DOS tools, which probably won't work on your Mac, for example, for parsing this data. But the book does have some tools that they present in Appendix A that use that baseball R package. But even then, it's still kind of a pain because I looked in there and it turns out that you need not only the baseball R package, but you also need this command line tool set. I forgot the name of it already. But there's some command line tool set that the baseball R needs to be able to parse the data. So that'll be interesting to see how that all works. So an example question for this would be like, what's the major league batting average when the conditional on when the ball strike count is 0-2. That's kind of detailed information you can get, or 2-0, because now you have all that information. You can do this kind of conditioning on the detailed plays. It's kind of the book actually. By the way, when I mentioned these advanced example questions, these are questions that the book presented, and he does give answers for that. Right? Turns out, as you might expect, that the batting average was higher when the count was 0-2 than it was 2-0. Mainly because the pitcher probably has less options what he can do, and then maybe the batter has more confidence, right? Or so the other way around. I should say the other way around, right? Because in this case, the batter's behind, so the pitcher's got more options. Whereas in this case, the pitcher's behind, so the pitcher's got less options, and the batter might have more confidence. I think that's right, Trevin? Mike, get that right the right way around this time.
Well, it sounded right.
Okay. But these are the kind of things you can put some numbers behind with the data, which is cool. So the next level of data, which I was kind of, so it's really cool. I didn't even know this was kind of stuff was available to the public. Is if you ever watch baseball, you'll see this little like rectangle on the screen, which shows where the strike zone is. You can see where the ball exactly hits the strike zone. You can grimace when the umpire calls it a ball when it should have been a strike, or a strike when it should have been a ball, in your opinion. And you have all this nice information available to you. And it turns out this is something we can also get. There's two sources of this data because there was a change, but the data consists of much more detailed data. It has the ball release point, the trajectory, the location, like I said, at the plate, and a bunch of other information. Originally, it was provided by a source called PitchFX, but in 2017-ish, I guess, it was replaced by the well-known Statcast, who's now doing not only the pitch location like this, but where all the players actually were. They have very, very detailed information. Most of that very detailed information is only available to the teams, though, for their analysis. So they give an example question here. What are the chances of a successful steal when the pitcher throws a fastball compared to when a curve is delivered? That's because it'll tell you whether it was a curve or a fastball based on the trajectory. They did the analysis. You don't have to reconstruct that, unfortunately. So this says Statcast is now the standard. They track all the much more information, including the movement of the individual players. There's limited data provided to the public through this website called Baseball Savant. And the Baseball R package gives us access to that and more, like I said. I think this is actually, so yeah, at the moment, by the way, if you just install Baseball R from the CRAN, it won't work. You need to get it from GitHub. This is kind of a problem for figuring how I'm going to get this onto our GitHub, because I don't know how to make this work properly with the description file. I have to talk to John about that. But in any event, if you do install from the current development version of Baseball R, then you can do things like, oh, give me all the stats on this particular player on a particular day. So I don't know why I didn't actually spit out the answer there, but
I think since you just assigned it to Noah, it
oh
didn't
yeah.
print out.
All right, I'll have to fix that. I can't remember what I actually said now. Let's see if I can run the cell here. That cell, see, I'm used to like Python thinking. Oh yeah, so I mean, I guess I could try to show this to you. Might be interesting. So this is what's in that NOAA variable. So it's got the pitch type, the release speed, release positions, player's name was Noah, of course, and what the battery faced was, what happened to that play, things I don't know what even is. Oh, just look, little text descriptions. That's kind of fun. There you go. Here's all the data on the release and where it crossed. This is the X, Y, and the plate. So you can reconstruct a diagram that shows where all those balls, all those pitch balls cross the plate. Cool. There's a lot of interesting information there. I mean, we'll hopefully have fun working with that soon. Switch back to the charts here. So he answers a question like how frequently do MLB teams employ infield shifts? Again, in the book, he answers these questions, not using the data. He answers them. He used the data, but he doesn't show you the steps that he took, as you remember if you read that chapter. I will mention that he doesn't talk about this, but I did play around with baseball a little bit. There's other data in there. You can go to the website for baseball and you'll see that there's all kinds of, it'll scrape data directly from Baseball Reference or from Fangraphs for you. And for example, you can just get, what's the current, well, this is current standings of April 16th when I did this, but you can, for the National League East. So you can pump out whatever, all the cool stuff that's on Baseball Reference and Fangraph. Well, not all of it, but a lot of it. Just kind of cool. And like I said, Retrosheet is also in the Baseball R, but you need a special command line tool to make that work. So in the book, he says he's going to use Lahman data from the Lahman package. So that's pretty straightforward. But other data is going to be that's in the package. And this is analyzing baseball data with our third edition data. That's strange language there was. That package has small examples for other data that we will be able to use in going through this book, but for larger data sets, we'll have to download the data separately. And I don't know what that's going to tell, how much that there is. We'll see when we get there. There's several exercises in there at the end. I thought it might be fun just to try to see if the idea here was to take, now that we've gone through and overview all these data, the databases and data sources, we could try to just figure out which of these relevant, which is the relevant data for these different baseball questions. So I don't know if anyone wants to take a stab at this first one here.
Would that be Retrosheet for the first one?
I don't know. I don't know the right answer. But it does say the per 9 innings, so maybe you could do it with the Lahman data set since that's the full, that would have the full walks, right? Per team per game. Right? No, it doesn't. No, you're right. I think you need the retro sheet game by game. Yeah. Yeah, Lahman doesn't have the game by game, right? So you're right, retro sheet. That makes sense. And for this, I guess I don't know why these got combined together. I didn't put a space between them or something. The next one is what fraction of baseball games in 1968 were shutouts? Maybe that one you could do with the Lahman database.
Yeah, that makes sense.
And then you could do that comparison with the same thing. And this one says what percentage of first pitches are strikes? That one you definitely could, those two, I think, right? You can answer with, well, I'll let somebody else answer. Anybody else want to jump in on that one? No? Well, I'm going to say retro sheet for that one since I know you can do it with retro sheet because it has that, tells you what the ball strike count was.
I'm wondering in general if, in addition with the Statcast data, are we mixing the R skills such as tidyverse, deepwire to help us with these searches?
Yes, yeah. Not yet, but we will be. In this case, it's just which data set we should use. But yeah, we'll definitely be using tidyverse in this book. This is just kind of a little fun exercise. Which database should we use?
Would any of these be Statcast and Baseball R?
Good question. Let's see which players are most likely to hit ground balls. That seems like you do that Retrosheet. Compare the speeds at which the ground balls are hit. That one you need Statcast or Pitch FX.
Yeah.
And the last one, I have no idea. It's easier to steal second or third base. I don't know if Retrosheet has that level of detail in the plate lines or not. Guess it should, right?
I would guess so.
Yeah.
I'm not sure if the baseball R, if the pitch FX era would have the added ball speed for ground balls or not, or if it would just be the Statcast era. I'm not sure of that.
Yeah, me either. Don't know. You not know. That's my overview of the chapter. That's how I tend to present these book club chapters. You just kind of a rambling mess like that. So hopefully other people can do a lot better. But anyone have any observations they would like to share about the chapter? Now would be the time to do it. Or about baseball, about anything. Life.
If you're using the baseball R package, it's definitely a work in progress and it's something that's volunteer driven. I know Statcast has some new data, like for example, they've added arm angle data for pitchers. I'm not sure if that's available yet through Baseball R. But there's definitely a list of issues on their GitHub. And if that's something that you're like really jazzed up about, you can also like help contribute to the GitHub package.
Yeah, and I would say also that if you have some parts of the baseball terminology you're not familiar with, feel free to ask on the Slack. If we'll try to help out as much as we can, or should say maybe Trevin and Derek, since they're probably a lot more knowledgeable about baseball than me from what they've been saying so far. But my knowledge is somewhat scant. But that's why I'm here. I want to learn more about that and how to work with the baseball statistics. And baseball's unusual sport in that it has so much statistics. Every play, like as we just saw, every play is documented, and it has been like that for a long time. It's the statistician's favorite game, right? Because it's so much data. Now all the other sports are catching up, but if you look at like soccer, or football, depending what country you're in, it's only now starting to catch up with more and more data. Before it's pretty scant data. It's like goals and assists, and that's about it, right? Penalties, I got penalties, but penalties. What do they call it? Warnings, red cards, yellow cards, whatever, that kind of stuff you can get stats on, but that's about it. It's because the plays are more fluid, right? In baseball, it's like a very structured game, so it lends itself to statistics, I believe. Okay, if there's no other observations, I'll do the end thing.